What is up, most distinguished patrons of this channel? Today, after 7 or 8 months of wanting to get around to this, we finally are there, and that is an introduction to TIG welding. And that's what we're going to be covering today. Let's get into it. So I find it kind of funny that I'm predominantly a TIG welder. It's my favorite welding process. It's my preferred welding process. I use it as much as I possibly can because I just enjoy it. And yet I've had very little content on this channel regarding TIG welding. Now, before my channel even was known to anyone, I guess, I did put out a couple simple TIG welding videos mainly to help people and to answer questions, but I've never really done a how-to video series. So this is video one in that series where we're going to sit down and talk about the introductions to TIG welding. And like I said, it is my favorite process. It's what I'm most skilled at, and I enjoy the most out of all welding, so this will be a treat for me to do as well. Now, TIG welding used to be kind of like a dark art where sorcerers and magicians did it. And luckily, more recently, in the last 5 to 10 years, it's become more of a household name instead of what the guys do that drool on themselves in the back of the welding shop. And I'm glad for that because it's more approachable than ever. Because you guys got to remember, when TIG welding was in its infancy, which was in the 40s, very, very few people had even access or knowledge of it. And then fast forward to the 80s, 90s, even the 2000s, early 2000s, it was still somewhat obscure. Like, you couldn't go into your local Harbor Freight and buy a TIG welder. And luckily, all of that has changed. More than ever, you can have access to TIG welding for both the welders themselves, the consumables, the technology, as well as videos of guys showing how to do it. So it's approachable, like the average person can get into this, and not to mention the costs have plummeted for the most part. Like, you have access to a simple DC TIG machine for under $500 that's actually functional and good, and that's never been a thing in all, the history of TIG welding, I guess. So with that said, I just want to put a disclaimer out here. This first video, we are going to be covering in depth a lot of the machines and the torches and the parts and how the process works, and there won't really be any welding in this video other than maybe a couple pictures to demonstrate something. So if you're already well versed with all of that, this video probably won't be for you. You'll have to stick around for all of the videos in the future in this series where I cover more things in depth, like fine-tuning fillet welds and outside corner joints and that sort of stuff, okay? But if you're new to TIG, if you're taking it as part of a college class or a high school class, this is going to be the video that will explain much of how it works in the machines and everything. This video will also be referenced by all future videos that I come out with, so it is imperative that you watch this to get a basis of understanding, so we're all at like level 2 or 3 after this video and not going in blind. Because this is one of those things where it's actually super simple, kind of like golf, but impossibly difficult to perfect. And that's really what we're dealing with. It's simple in theory, not impossible. I hate to say it, difficult in practice. That's TIG welding in a nutshell. So the first thing we need to talk about is, what is TIG welding? So we're all on the same page. We are talking about TIG welding, which is what I call it, which is what most people who weld call it, but the technical term is GTAW. If you're in school for welding, that's likely the course title that you're taking. That stands for gas tungsten arc welding. Since it uses an electric arc to weld, it is part of an arc welding family, so this is one of many arc welding processes. The gas that is used, which the G is for gas, is either argon or helium gas. Now, a blend of the two can be used, and to be honest, most of what you will ever have experience with, unless you work for NASA or have an unlimited budget, will probably be argon gas. Argon gas is cost effective. It works as an inert gas, so it shields the tungsten on the torch from oxidization with oxygen, which is hugely important. We'll talk more about that later. Helium can also be used. However, helium is so extremely expensive right now that nobody uses it. It's basically impractical from a cost perspective. Now, there are certain benefits to helium, more on that later and in later videos as well, but we will talk a little bit more about that in this video. Now the polarity, because it is an electric welding process, it does have a polarity, is DCEN, so electrode negative. The torch itself gets hooked to the negative output of the welder and the ground clamp is on the positive. Or it can weld on AC for the case of aluminum. So depicted here is a TIG torch, and we will look at a bunch of actual ones in a minute. But you have the torch body, you have a ceramic nozzle, and then you have the all-important piece of tungsten. Now, the T in GTAW and the T in TIG welding, which by the way, TIG stands for tungsten inert gas, is this piece of metal here. This happens to be a jumbo 1/8 inch tungsten, which is pretty uncommon for most people to use in a home. Normally it's a 3/32 or smaller tungsten, but it works better for filming purposes to have this big one here. Now, this is not steel, it's not stainless, it's actually tungsten, or as you super cool people overseas call it, wolfram. What this does is it's basically an insanely high melting point metal that can pass electricity into what you're welding and not melt itself, which is very handy because essentially in the TIG process, what you're doing is using the torch as a form of heat per se. It's just a concentrated electric arc. If you didn't use tungsten and you use something like stainless steel, it would just melt, and guess what? You can't actually weld. So tungsten is the critical element to make this work. Now, the melting point of this is so high that it's basically higher than almost anything I could imagine that isn't radioactive, and that is why they use it. You're not going to find too many other suitable replacements for this because, well, like I said, the radioactivity of other elements or other undesirable properties of them make this the go-to metal for this process. Now, the TIG process operates on what's called constant current. So it functions just like stick welding, where you set a base amperage and then you can either run that fixed amperage, or in most cases with TIG welding, you can use a foot pedal to control amperage. And what you really have to think of this process as is an electric torch. It's like a very precise oxyacetylene torch where your molten pool is super small, you have immensely high heat levels, and it's just so precise you can just do exactly what you want to with it. It is actually very forgiving when you learn the process, but the process of learning it is quite difficult. It's kind of like learning golf. You suck for about 10 years and then you get good at it. No, actually, it doesn't take that long to get functionally good at this, especially after the videos I'm going to make to help you guys. It'll be a lot faster than 10 years, but it is a time commitment, no doubt. So let's go and look at some actual torches. So in front of us, I picked out 3 TIG torches, and these are slightly different from one another, but this kind of shows the broad range of different torches you can buy, and I think it's important to understand all of them. That way you're not surprised if you happen to get one of these styles instead of what you're used to. So all of these are somewhat functionally similar in the sense that you have a power cable in here. In all of them, this one happens to be very small and flexible, but you have a power cable and a gas hose. Now, how that is set up is different depending on manufacturer. It may be a separate gas hose in here, or it may use the tube itself as the gas hose. Doesn't matter. Argon gas or helium, which for all practical purposes is going to be argon, flows through here, and current flows through there as well because of the power cable. It goes into the head of the torch, and then it goes into the tungsten through a collet. Now, this has a pre-dipped tungsten already in it, and the current passes through that tungsten into your workpiece, more or less. So that is similar among all of these. Now there are obvious differences. So this is what I would consider the standard TIG torch. This is what most machines come with, is a simple, no knob, no button, very simple torch. Some of these, like this one, is a flex head. Most of them are not. It is a good idea to get a flex head if you don't have one. This guy right here is what's known as a torch valve torch. As you can see, it has a valve on it. This is primarily designed to be used with stick welders or with TIG machines that don't have a gas solenoid. So essentially, to get the argon flow, you crack that open and now you can weld. The downside to this is you're going to waste a lot of shielding gas, especially if you forget to shut that valve. But this is a very economical torch that you can add to any stick welder in order to TIG weld on that. More about that later. Now here is more of a fancy state-of-the-art style torch, and this has amperage controls directly on the torch, which is different than these. So we have a button likely to start the arc and to stop it, and then one to go up and down in amperage. That allows you to control your welding current without using a foot pedal, which is handy if you're like under a vehicle or something. And you'll see any number of different torches like this. And for the most part, most machines do not come with a torch like this. This is something you would have to buy separately. Handy in certain circumstances, I generally prefer something like this. So let's look at a quick breakdown of the parts of this. So in front of us here, I've disassembled this TIG torch here, and this is going to be similar to most standard torches. So you have your body here, the power cable comes in, it is likely soldered onto this brass fitting that is over molded, and then your collet body or your gas lens threads in here. So this more or less becomes electrically live when you're welding, and it passes current into what holds the tungsten, which are these, and there is a tungsten. Now, this setup is really simple. Here's your torch. You have a back cap. The back cap presses on this, which this is a collet. Which is a simple collet body. When you slide that in there, pressure gets put on this right here, and that just clamps the tungsten in here, as you can see. And that tight fit is what allows the electrical energy to pass through the collet body into the tungsten. If you ever have the wrong components for your torch, and this is not tight where you can pull a tungsten in and out, you're going to have all sorts of issues and likely excessive heat in the torch head because of the resistance. Now, the tungsten more or less just gets clamped and electricity passes through it. Now, this is a collet body. This uses simple gas cups which thread on there, and as you notice, there is no screen or anything in there. It's just a wide open hole. You can also get gas lenses, which is similar to a collet body. It functions just like it in a sense of clamping the tungsten. However, there is a mesh screen. The purpose of this mesh screen is to create what's known as laminar flow of the gas, which in very simple terms just means non-turbulent gas flow, which provides better shielding. And since you need argon shielding to weld with this process, better shielding often means better looking welds as well as less gas usage. So I personally only use gas lenses, and collet bodies I'll only use occasionally for aluminum. Here are gas cups. They're made out of ceramic. There are glass ones out there. I would highly recommend against the glass cups when you're learning, because if you break one, you're out quite a few bucks for that, and I don't find them that beneficial, to be honest with you guys. I myself primarily use ceramic cups and have had no issue with them. Now, this little white spacer is a spacer, just like I called it, and that has to be changed depending on what cup you're using. As you can see, this works just fine. As you can see, this does not fit in the hole properly. So you must use the proper spacer for the cup you're using. It is possible that the TIG torch you're using does not use one of these. It all depends. Different brands do different things, but universally most brands out there will use at least the spacer on the front, and some of them use one on the back. Speaking of the back, there's all sorts of back caps for these things. I tend to use a medium size. There's little bullet sizes that are just a cap, and then of course the full size one. What I find is this big long back cap just gets in the way more than it's useful, so I tend to use a medium one. These things can be useful to hold a torch such as this to help steady yourself. So I generally will run a cap of some sort. By the way, there's an O-ring on this, and occasionally there's O-rings as part of this assembly with the gas lens. If those leak, you can either end up getting less argon out of your cup than you expect, or it can pull in air from the backside and contaminate your tungsten and your weld. So it's important that you keep O-rings in good shape, like this guy right here, and you replace them if they're nicked or missing, because it will cause issues. So now that you understand the torches a little bit better than their components, let's talk a little bit about what the hell is actually going on when you TIG weld. So depicted here, we more or less have our gas cup, which is right here, our collet body or gas lens that allows the shielding gas to flow through the torch head to shield our weld area as well as the tungsten, and then this line depicts our tungsten. Now the shielding gas comes out and actually shields not only the tungsten, not only the weld pool, which would be depicted like right here, but it also shields this area around here, and that becomes very important when welding reactive metals like stainless and titanium, which are very reactive with oxygen, where you need a lot of shielding gas. Well, this purple shielding gas here shields all that, and argon, being that it's inert, more or less just keeps oxygen out of the area that would otherwise contaminate and react with your molten metal or the red hot tungsten. And that's very important because tungsten will only handle high temperatures when it is not exposed to oxygen. So that flow of argon will protect that tungsten and allow it to glow red hot, white hot even, without melting. If you were to remove the shielding gas, what would end up happening is the oxygen in the air that you breathe would react with that red hot tungsten, and it would be consumed. It would basically burn up much like a sparkler in a very short, like a second or two. Anyone who has ran out of shielding gas or forgot to turn it on can attest to that, would definitely know what happens then. So anyways, the current that you typically weld is steel, stainless, titanium, Inconel, all common metals other than aluminum and magnesium, is DCEN. The electrode is negatively charged, and the plate is more or less the positive charge. And electrons flow from negative to positive, therefore it produces a very narrow arc cone that's very focused, very high heat. When you weld with AC current with TIG, that you have both a mix of about 70% negative, so negative to positive, and about 30% positive to negative. So you actually have a return current from the base material to the tungsten tip. And when I get into videos welding aluminum, I'll explain that more in depth. But for right now, you just need to understand that AC current is required for aluminum and magnesium with TIG under most circumstances, and that the AC has 25 to 30% current back towards the tungsten. Now, speaking of that, I will put this caveat into this because welding is an enigma. Every time you think you understand everything about it, you find out there's something you didn't. It is possible to TIG weld aluminum on DC. However, you need 100% pure helium to do it, and the cost of that is probably more than a cheap TIG welder. So it's not really a viable option for most of you out there. I had to put that out there because someone in the comments will say, well, what about helium and DC? So yes, you can weld aluminum with helium on DC, but it's not practical due to costs. So back to what I was talking about here. TIG welding operates on constant current. So it runs like stick welding, where you run a fixed amperage, or you can control it with the foot pedal, and your voltage is whatever your arc gap is. So a lot of people are under the false assumption that voltage doesn't play a role in TIG welding. It absolutely does. The difference is, like on your MIG machine, where you have a separate dial to adjust voltage, where MIG and gas metal arc welding, so wire welding, runs on fixed voltage variable amperage. TIG and stick welding runs on constant current, so fixed amperage variable voltage, and the voltage is whatever your arc gap is. So the arc gap is your tungsten to your work. Now, this is grossly exaggerated to how big it is. If you had this much of an arc gap, you would be melting all sorts of stuff. The arc gap necessary for this process to work is somewhere between, I would say, 1/16 and 3/32 of an inch. It is a very minuscule arc gap. Like, I would depict it right now, but you wouldn't be able to tell on film how tight it is. And we'll do a little bit of a picture of that later to describe the actual gap you need to maintain. So anyways, I think that you understand this pretty good at this point. Let's talk a little bit about machines. In front of us here is this Vulcan Pro TIG 165 that I picked up, which, by the way, I will be giving this away in a few months once this whole video series is wrapped up and I've covered everything I think I need to cover to teach you guys. So pay attention to that down the road. Anyways, this is a very simplistic TIG welder, and this would be representative of an affordable one you might buy on Amazon or eBay, or an older unit that you picked up used on Marketplace. When I say simplistic, what I mean is it has a simple dial. You just adjust the amperage to whatever you want, and then you would use a foot pedal to control the amperage. Now, this machine can do both high frequency start and lift start, which I will talk about that after we get through the machines. But the amperage is simple dialed. There's no LCD screen, there's no settings really to adjust. It's as simple and basic as you can get. And funny enough, a machine like this is actually capable of doing TIG welds that would meet aerospace specifications. And that's something you're going to find with TIG is heavily dependent on the person doing the welding more so than the machine. I own a $5,000, $6,000 Miller Dynasty, and when it comes to running a simple TIG bead on steel, the difference between this at a couple, say $500 versus a $5,000 Dynasty isn't hugely different. Don't get me wrong, there are differences, there are huge differences, but to do quality welds on simple materials like steel, you can do that with this machine. And that's one of the great things with TIG welding in general is, sure, the cost to buy the machine up front is a little bit pricey, but the capability that you get on the quality of what you can weld, your weld quality, is unbelievable, and it's really unmatched, especially because you can weld any thickness with TIG without any real detriment or any issue. But again, more on that later. So anyways, this machine is a simple machine. Even simpler yet would be something like the Dial Art 250 I have, which you can TIG weld with that as well. Now, any stick welder that's out there that does DC, you can TIG weld with if you get a torch like I showed you earlier in the video with the gas valve on it. Don't get me wrong, it's not the easiest way to TIG weld because you have fixed amperage, you do not have amperage control, but you can TIG weld with it. Now, back to talking about this machine. This is just like every TIG machine in the fact that it has an amperage maximum that it can output. In the case of this, it's 165 amps. Some machines out there are 200. You have industrial machines that are 300, 400, 500 amp machines. The importance of getting a big enough machine can't be overstated. This machine at 165 amps would tackle most things that you might get into just fine. Keep in mind, this is a DC only machine, as are universally all cheap TIG welders, and you cannot weld aluminum with this machine. and I'm going to say that one more time to beat a dead horse, you cannot weld aluminum with a DC only TIG machine unless you get a $500 bottle of helium. And I don't think you're going to do that. So for all practical purposes, you cannot weld aluminum with a DC TIG machine. The reason I said that so many times is because I can't count how many times I read in the message forums or on a review of a particular welder online where someone says, oh, it's a great welder, but it's BS that it doesn't weld aluminum. Well, guess what, buddy? That's on you for buying a DC machine and thinking you could TIG weld aluminum. The problem with the whole situation with the AC being required to weld aluminum is that you can pick this welder up for $500-600, right? And weld anything you want but aluminum. The cheapest functional aluminum welder out there that is capable of AC TIG welding is probably $800, and less money than that, you're going to get a subpar machine that isn't worth the money. So that is a limiting factor. If you have ambitions on welding aluminum, you're going to have to come up with at a minimum of $800 to get a functional setup for a brand new machine, and it goes drastically up from there. So most of the money you're going to spend on a machine comes down to two factors. If you need AC for aluminum, that's going to cost you a bunch of money, and the more amperage you want is going to cost you a bunch of money. But like I said, 160 to 180 amps is enough to TIG weld most things that you would ever run into. So let's talk a little bit about how these start the arc and why that's important. So starting the arc with the TIG welding process is actually pretty simple. And there's two primary ways to do that. What's known as high frequency start and then lift start. There's a third one that's called scratch start that primarily comes into play with stick welders that you happen to be putting a TIG torch on. I'll talk about that when we're done with these two. So high frequency start is really pretty simple. Here we have our gas cup and our TIG tungsten. What the high frequency start does is it sends a high voltage, high frequency arc through the tungsten into the workpiece, much like this. And once that completes a circuit, the welding machine triggers the main welding arc, which then more or less piggybacks on that pilot arc to start the arc. The reason that that is needed is because when you have argon gas around in here, and you're trying to start an arc, even though your TIG tungsten is super close to that metal, that arc gap is still too much for the voltage to overcome when there isn't an arc present. So that high frequency arc more or less creates an initial arc for the main arc to piggyback and ride on in order to start. And it happens so fast, most people never even notice the high frequency arc. It just kind of pops and it starts. Now, not all machines have high frequency arc starters. A lot of older machines are all lift start, and we'll talk about that in a second. So it's imperative, if you want high frequency arc starter, that you verify the machine you're buying has it. The benefit of high frequency is that your TIG tungsten at no point, just like this marker, touches this base material. It's far easier to start an arc that way, especially in confined spaces. I find that I use high frequency for virtually everything, unless I'm in a very tight spot and can't use a foot pedal. So high frequency is the way to go. If you can't afford it or your machine doesn't have it, so be it. You can get by without it, but it's very handy to have. Now, lift start, which is depicted here, you have your TIG tungsten here, and more or less what you have to do is touch that tungsten to the work. And I have my tungsten right here. You touch it, and then you lift it off to the proper arc gap, and the machine will start. And it has to do with built-in capacitors that will drive the voltage temporarily high in order to cross that arc gap, and it knows to do that when you touch it and then bring it up. And lift start is very popular with guys that weld pipe in refineries and factories because they're not commonly using foot pedals for control, and they're running fixed amperage. So say 90 or 120 amps, well, you just touch the tungsten and go, and now you got your arc and you do your welding. It eliminates the need for a foot pedal or a torch switch or some means to start the arc. Very handy in some circumstances. For general fabrication, it's far less preferred for me and for most people. The downside really primarily comes from when you touch the tungsten and you lift it, the possibility of getting the tungsten stuck to the material, depending on how good its lift starting mechanism is pretty high. And if that happens, you now contaminated your base material with tungsten, and that can be a point where a crack will form, so it's undesirable. It's much easier to get clean starts, obviously, with high frequency. Now, there are some benefits to lift start. Because it's not using a high voltage, high frequency pilot arc to start the main arc, it doesn't interfere with electronics. And I myself used to kind of say, that doesn't matter. And then I noticed that the high frequency starters on a lot of my welders I've had, when I would start the arc, weird things would happen, like Milwaukee tools, the lights would turn on them even though they were like 2 feet away. So it does cause interference with high frequency starters that lift arc does not. So in sensitive locations, that may be preferred. Now, the third method to start a tungsten, besides dipping it in the molten pool, the third way is what's known as scratch start. If you're familiar with stick welding, it's the same concept. You bring the tungsten down, and in one motion, you touch it, lift it, and the arc starts. So it's just like a stick electrode. Massive downside to that is because you have full power live at that tungsten tip at all times, when you come down and touch that and then lift it, what can end up happening is it welds itself right to the plate if you're not quick enough. Just like a stick electrode can be stuck to the plate, same thing can happen with the TIG tungsten. For you learning at home, unless you're on a stupidly low budget, which, hey, we all have budgets, right? And you're using some stick welder, I would highly recommend against scratch start. It's a lot harder and you're going to be frustrated. And part of TIG, what makes it so hard to learn, is getting through dealing with being frustrated over just how difficult it can be initially. And adding more variables like stuck tungsten is not good in my opinion. Once you get good at TIG, sure, you can do scratch start all day and it's not a big deal. But stick with lift or high frequency if you can get it. So let's talk a little bit more about machines. So as far as amperage control is concerned, TIG welding is unique in the fact that you more or less can use a foot pedal with most machines to vary your amperage output. So just like I described the TIG torch being more or less like a very precise oxyacetylene torch, this is your control. More heat, less heat. That is unique. The MIG welding process and stick welding, you put your variables in the machine, you pull the trigger or strike the arc, and now you're stuck with whatever you set up. So that is a huge benefit because as you're welding thick and thin material, you can vary your amperage to exactly what you need to perform the perfect weld on them. You can also weld materials like aluminum, where you put massive amounts of heat to get it to weld. The middle part of the weld, you're kind of half off the foot pedal where you're at more or less medium heat input, and then at the end of the weld you can be almost off the pedal to where you're not blowing out the end of the weld. So this device more or less gives you super control over heat input. And this is probably the hardest thing to master with TIG welding besides controlling your arc gap. This can get you in a lot of trouble, and that's why when I teach people to TIG weld, I generally eliminate this variable from the process. And what I mean by that is I just set the machine for a fixed amperage and tell the person to go full pedal and forget about this, because you need to be able to master an arc gap and arc control and travel speed and movement before you worry about where your foot should be on this. But since this is part of TIG welding, I have to mention it. Now, this particular foot pedal is a wireless foot pedal. I love it because I hate cords running all around the shop. If I could have a wireless TIG torch, I would, but obviously that technology does not exist yet. But most of them out there are wired. If your machine does not have a foot pedal and you just run fixed amperage, you can TIG weld with that. It's just far more difficult. Now, some torches like this Fronius has a amperage control on the torch where you can go up and down in amperage directly on the torch. Now, some of them, like this one, you can do it while you're welding. Other torches, it only functions before you strike an arc. After you strike the arc, it doesn't adjust anything, so you have to look into your machine to find out how it functions. But that is pretty handy because you could weld, and if you need more amperage, you just move the switch up or down, and it negates the use of a foot pedal, which is, say, a roll cage in a car. Very handy to have versus fixed amperage. My recommendation is 100% get a machine with a foot pedal. If you don't have a foot pedal, you're missing out on 90% of what makes TIG welding great. So you understand how the arc works. Now you have to understand how you add filler, or how you actually make a weld. With the MIG process, where you have a gun that feeds wire, and the wire is both the filler material and electrode, same thing with stick welding. Well, TIG doesn't deposit metal via the arc. All this torch is used for is more or less controlled heat. So you can use that controlled heat to weld two pieces of metal together in a lap weld or in a butt joint, where you can just fuse right down and not add filler material. Well, the problem with that is your weld is going to be pretty weak. You're going to more or less have just undercut, and depending on what you're building, that might break. Well, that's where the filler metal comes in. This piece of wire, which this happens to be 1/16 filler wire, they come in all sorts of sizes. You can create that molten pool, because again, this is more or less just an electric torch, and you're melting metal, and then you feed the wire into that molten puddle, and you just kind of push a little bit into it. And by doing that, you're adding reinforcement, or you're more or less adding weld material. Now, the welds that the TIG welding process produces are extremely small. If you're used to stick or MIG, where you can lay down, you know, a nickel wide pass, TIG is not that process for you. TIG is a very precise, low deposition, extremely slow process. So it is not very good to do high production work with it. It simply is too slow and too small of welds. But for super precise welds, you really can't beat it. One of the great benefits to having separate wire like this is you don't need to buy a 5, 10, 20, 33 pound spool of MIG wire or 5, 10 pounds of rods. You can get a 1 pound package of, say, stainless wire, titanium wire, Inconel, whatever, aluminum, and you're not buying massive quantities, and you can keep it around for that odd stainless repair job that you might want to do. So it's very economical on small repair work, because you're not sitting around with 5, 10 plus pound spools of wire. Also, you only need 1 bottle of shielding gas for the TIG process. Like I had mentioned, a bottle of argon, and you can weld stainless, titanium, Inconel, anything, aluminum. So that also adds up to cost savings over the MIG process. So in front of us, I have 2 additional TIG welding machines, or at least machines that are capable of TIG welding. The Miller Dynasty 210, which is sold and predominantly a TIG welder. Obviously, we already talked about the Vulcan. And then we have the ESAB Rebel 235. Now, this is predominantly sold as a MIG machine multi-process that happens to be able to do TIG. However, the TIG functionality of this machine is far less, I would say, than the Dynasty, and in a lot of ways less than this, and that is because it does not have high frequency start. Now, this video is not going to be a how to pick out a TIG welder for your needs. I'm going to do a whole video on that to explain what you should look for, but we need to at least talk about the differences here so you have some kind of basis. Now, this will start out with the Rebel. The Rebel is an awesome machine. They make multiple different types of this. This is a DC only machine. The only ESAB Rebel that they make that is capable of AC is the Rebel 205 AC-DC. That machine can weld aluminum with TIG. Now this machine can weld aluminum with a spool gun with MIG process, but it cannot TIG weld aluminum, again, unless you have that bottle of helium for 500 bucks. So if you're looking at buying a multi-process machine, first thing is I would recommend against it. But the second thing is, if you want aluminum capability, you must buy an AC machine. And unfortunately, the AC capable machines like this are $3,000 to $4,000, which is a significant amount, and that's why I don't recommend getting an all-in-one unit, because the cost of them are extreme, and the quality, or not quality, the capability I find is less on an all-in-one than separate machines, which actually cost less. So like I said, this machine is predominantly a MIG welder. The TIG welding capability, limited to DC, it is limited to lift arc. This does not have a high frequency start. So this would work fine if you want to screw around with TIG, but to do a lot of TIG work, you're going to want that high frequency start, and this simply doesn't have it. This is an excellent stick welder as well, and its output capability actually surpasses on DC TIG the Dynasty by a fair amount. This is capable of over 230 amps on DC, which is quite a bit. And in the future, I will likely have projects that need that kind of amperage on DC TIG. This is what I would use over the Miller Dynasty. So with that said, let's look at the Dynasty. Now, the Dynasty is the latest, hottest, coolest. It's got a digital interface, does everything. Do you need something like that? Absolutely not. For the average person that's learning to TIG weld, you're far better off buying a machine like this that has the good features that you want, and then upgrading to something better later. And for the average person, it's just like golf. TIG welding is one of those things where this machine is like the $5,000 club set. Will it make an average golfer better? No. It will make them slightly better, yes, but not. You're not going to be entering the Masters anytime soon, if you know what I'm saying. However, there are features on that machine that when you're at an extremely high level of skill, or you want to weld extremely thin material or aluminum, that are invaluable. And that's really the difference that you're going to find. And I hate to break it to you guys, because I don't BS here. When you get into cheap welders, what you're going to find with TIG is their arc starts are real harsh. Like you try and start the arc and it blows through the material because it's a 20 or 30 amp arc start. When you get into a machine like this, or a professional level machine, you can arc start on a razor blade or paper thin aluminum and not blow a hole. Most things that doesn't benefit you, but if you're welding super thin stuff, that does. And the level of control you get when you get into professional level machines is just, everything is better. That doesn't mean you're going to be a better welder, especially if you don't know how to adjust those settings, but higher end machines are generally better. And there is a limit to the low end that you want to go. When you start getting into machines from Amazon, the quality of what you're getting is so poor, and you might not realize it. But like something as simple as you want, say, 75 amps, and I set it for 75, you might be getting 100. And that's the problem, is that when you get cheap machines, the accuracy of your set points is off, how good the foot pedal works is poor, your arc starter's harsh, etc. So it does pay to get a functionally good machine and something decent. Stick welding and even MIG, you can cheap out, but with TIG, you really need at least a halfway decent setup, or you're just going to be more frustrated than anything. Now, as a brief overview on cost, I would say the bare minimum machine that you're going to want is going to cost somewhere around $300 to $400 for some kind of machine like this or equivalent. That would be a great place to start. To get AC capable, you're looking at $800 to $1,000 to weld aluminum. That's the bare bones, or pick up something used for less. To get into high-end machines that have full control and the best of the best, you're looking at a minimum of $3,000 investment on a machine. Yes, it's expensive. The great news is, guys, you don't need to spend that much money to do a really good job. And by the end of this TIG welding series, which is going to go on for probably a month at least, I will prove to you that you can do exceptional welds with minimal equipment. And that's great news for you. You don't have to start out with the best to do a hell of a good job. All right, let's go back to the welding bench. So there's a couple more tidbits of information I think are very important for you guys to understand about this process. And the first one being, it's not as hard as it seems. And I know if you have any experience with TIG welding or you just started to learn, you're like, man, this is so difficult. And I'm going to sum it up as this. If you were to try and balance a basketball on your fingers, it's going to be pretty tough and it's going to fall down a lot. Imagine if you practiced 5 hours a day for a month, you probably would be able to spin that basketball on your fingers pretty good, wouldn't you? TIG welding is the same thing. It takes that practice of the balance of maintaining your arc gap to consistently, not perfection, but very consistent arc gap, and being able to move your hands together to add filler and move the torch, etc. And the only way to develop that skill is no different than balancing a basketball or learning a guitar or an instrument. It takes repetition to where you don't have to think about what you're doing, you just do it. And it's easier than you would think. And one of the great benefits with TIG welding over any of the other welding processes is that if you can weld steel in the flat position, you can weld it vertical up and you can weld it overhead easy. When you deal with stick and MIG, anyone who knows how to do those knows that vertical up welding is far more difficult than horizontal, and overhead welding is more difficult than flat or horizontal. And that is one of the great benefits with TIG because of how it functions in your molten pool. It's far easier, other than finding hand position, to do vertical up, to weld vertical up than the other processes. So once you master flat position welds, it progresses very fast to out of position welds. And like I said, you only need 1 bottle of argon, which reduces the overall cost. If you can weld steel with TIG, you can weld stainless, titanium, Inconel, and even braze steel with silicon bronze. It all transfers over. Now, aluminum is its own animal that's completely separate, and no, just because you can TIG weld steel does not mean you can competently weld aluminum. It's not that hard, but it's a different skill set. But what other process out there gives you that ability to weld all common materials other than aluminum with very little differences between them? There isn't one. TIG is very good at that. And even though the machine cost is very high up front, you get back savings by not having multiple gas bottles, and by investing the time up front to master simple welds, the out of position is so much easier that you can actually become a functional welder faster, I believe, with TIG than many of the other processes. Now, speaking of other benefits, there's actually a lot of them with the process. If you want to weld thin material, so 3.2 millimeter or 1/8 inch or thinner, TIG is exceptionally good at that. You can weld 26 gauge or smaller material, thinner material with TIG, versus a lot of the other processes like stick, it's impossible to weld 22 gauge. Good luck. The ability to weld aluminum with the same tank as steel is also a cost savings if you buy an AC machine, so that is also a huge benefit. You also have the great benefit of no post-weld cleanup. You don't have spatter if you're doing the process correctly. You don't have porosity generally unless you're welding over poorly contaminated or poorly surface prepped material or oils. And the heat input, depending on what you're welding, can be fairly high, but at the same time, because you can deposit smaller welds than a lot of the other processes, you can actually limit the overall heat input to where the temperature of what you're welding doesn't grossly exceed a threshold. So a great example would be tool steels can be welded with TIG welding, whereas a lot of the other welding processes would be far from ideal. Now, there are some serious drawbacks to TIG welding. One, the initial learning curve is very steep. You're going to spend probably a month to a month and a half of practice before you become even remotely functionally decent at gluing stuff together without weld problems. So decent in the flat position. That's a lot of time commitment, and a lot of people fail in that more so than anything when learning to weld. So keep that in mind. The second, and honestly my opinion on what the biggest drawback is it does not handle surface contamination well at all. Even mill scale on steel will cause it to weld poorly. So your material must be clean, bright, shiny steel or aluminum, whatever it is that you're welding on. You are not welding over oil, rust, grease, any of that. This is incapable of welding over that, so it must be clean, and for a lot of stuff, that's simply not possible. Another downside is the speed that you can weld at. It sounds trivial, but if you're going to build a bunch of stuff, like say a whole roll cage for an off-road race truck, if you're going to TIG weld it, you're going to spend days more welding over the MIG process. And how much are you really going to gain in strength? Well, it really depends on supercritical, highly stressed components. This is the way to go. On average components that aren't going to see a lot of stress, TIG welding them more or less might be excessive. And you got to remember, because it's so slow, it costs a lot more money to run. Now, I haven't done the actual math, but I have a feeling that MIG welding, due to the production volume, even in a home shop, has got to cost half of what TIG does. So that is somewhat of a drawback. On the benefits side, TIG welding, and pretty much any TIG welder can stick weld. That's an awesome feature because you don't need to buy a separate stick welder if you get a decent TIG welder. Now, the downside to that is not all TIG machines are decent stick welders. Even though, yeah, they can all stick weld, most of them will not run 60-10. They typically run 60-11 poorly. A lot of them, especially the all-in-ones and any of them cheap Amazon specials, they're not running 60-10, I guarantee you it. So the stick welding performance of most of the cheaper ones isn't good enough to really call it a stick welder. If you buy a higher end one, they can typically weld with stick really well, so that's an added benefit. Beyond that, TIG welding, once you get a handle for it, it's probably the most relaxing and just pleasant to use processes because it's quiet, the arc is so smooth, and it's just something about it is mesmerizing. And if you haven't done it, I would highly recommend you give it a shot at some point just to get a feel for it, because I'm telling you, if you enjoy welding, there's something about TIG that's just, it's mesmerizing. Now, with that said, let's talk a little bit about the arc gap required, and then we'll go to conclusion. So sitting right here is a 1/16 filler rod. Very small. That is approximately the arc gap that you need to hold. Now roll that out of the way in order to TIG weld. Your tungsten, if it gets too long, will widen the arc cone and it would put excessive heat and the arc will wander. If you get too close, the tungsten will melt into your base material. You don't want that. So you're maintaining about 1/16 of an inch gap, and generally you use a pushing motion with the TIG torch. So what did we learn today? Well, we learned the basic of TIG torches and machines and how the process works, and limited amounts of information of everything else. And that is why this is the introduction video. We need to cover a little bit of the basics to where we can now get into the actual how-to with arc footage and all sorts of information regarding that. Now, I'm going to end this video with a couple statements that I really want you to understand and take to heart. You must buy a machine that is functionally decent to get any kind of acceptable results with TIG. All of these companies out there on Amazon will be happy to sell you some junk machine and take your money, and you, being a new welder and you don't understand what you're not getting, will buy that machine, and you're going to be frustrated and it's not going to work properly, and then you're going to write off TIG welding in general. And I hate to see people do that, but it happens more than you would realize. There is a bottom dollar that you need to spend to get a functionally decent TIG machine. And if you go below that or buy an Amazon special, all bets are off as to what you're going to get. And kind of like I alluded to earlier, the biggest crime that they commit is they'll claim, 160 amps of output and it only puts 120 amps out. They'll claim that it goes down to 10 amps or 5 amps, yet it goes down to 30. They'll claim a 5 amp arc start, yet it starts at 30. All of those things make it far more difficult than it needs to be to learn to TIG weld. So there is a limit, and if you're not willing to spend around $400 on an entry-level piece of DC TIG welding equipment, your outcome is going to be severely limited because of that. I hate to tell you, that's my opinion, and I'm sticking to it. Now, besides that, I'm not going to sugarcoat this, guys. TIG welding has a very steep learning curve, just like balancing that basketball. But once you get that, everything else becomes easy with it. So you have to stick to it, you have to commit to it, and you have to practice. If you do those things, TIG welding will come to you, you will understand it, and one day it's all going to come together in a soup, and you will be able to eat that soup and make use of it. That's the best way I can describe it. And I can't stress how important it is not to give up when learning. This is the process that the reason that nobody's good at it hardly is because people give up before they even start to learn it. For the same reason, there's very few people that are really good at playing a musical instrument. It's effort. There's no magic ability that I have that you don't that means that I can TIG weld and you don't. It's simply effort. With that said, hopefully this video served as a really good intro to you. And all the future videos, we're going to be dealing a hell of a lot less on the basics and more of how to actually get the results you want. So with that said, thanks for sticking around for the video. Until next time.